So in this video, I want to give you another example of a repeated measures factorial because I know it's pretty complex and difficult to understand. So in this study, I'm just going to give you the background of the study first, and then we'll get into how you analyze the data in SPSS. But in this study, we had people look at images of abstract art, and we did this so that they would have really weak memories. And so there were actually two tests. It's actually a little bit more complicated than this, but just for our purposes of the example here, there's two tests, and they had 50 old and 50 new pictures on both of them, and on these two tests, right? Pictures of these abstract art images. On one of the tests, though, we told participants that there actually would be more old items. So they were told that there would be like 70 old and 30 new. So they were expecting more old items. So we're going to call this the old expectancy, or OT for old test, to simplify our variables. On the other test, we changed expectancies like you might imagine. In this case, they were expecting more new items. So they were told there would be 70 new items and 30 old items. And so we're calling this the new expectancy test, or NT. In reality, there was 50 old, 50 new. We were just looking to see how expectancies would alter people's performance, and we also measured brain activity too. So on this recognition test, you can have what's called a hit. That is when you have an old item and you call it old. So you correctly identify an old word. You can also have what's called a false alarm. And a false alarm, which is often abbreviated, I'm going to abbreviate it FA, false alarm. False alarm is when you have a new item and you call it old, right? So in that case, you're falsely claiming a new item was actually studied when it wasn't. So that means, let me get this out of the way. So that means that we had two variables here. So we have the kind of test, so old expectancy, and so that's the OT test. And actually, I can make this a little bit bigger. Let me make this a little bit bigger real quick for you here, so you can see it a little bit better. And then we had the new expectancies test, right? So that was another variable. And then what we're going to look at is we're going to look at the type of item. So either a hit, right, that's old, called old, or false alarm. Now, so we have a 2 by 2. Both of these are within subjects because people completed both of these tests. They also had hits and false alarms on both of our memory tests, recognition tests. So I'm going to fill in some of the details just so you can sort of see what's going to happen, but we'll see this in the SPSS output in just a second. But this is the proportion. So they remembered about 65%, 66% of the old items. This is the standard deviation on the old test. They had fewer hits. Might expect that. We were expecting that. About 46% on when we changed their expectancies, right, on the new test. False alarms, you're going to see a similar kind of difference in that they had a lot of false alarms here. This is a huge number of false alarms. They're calling a lot of new items old, well, because they were expecting a lot of old items, so that's what's going on there. Remember, this is really weak memory, so they weren't real sure about what they actually studied or what they didn't study. And then had very few false alarms here, because they were expecting, a lot of new items on that, so they were much more guarded. So we got a pretty clear result here. You can kind of see that a lot more old responses here overall compared to the new expectancy test. You'd pretty much expect that. And then, of course, we had, in both cases, there were more hits than false alarms. That should make sense to you as well, because this is a correct response. They did complete a memory test after all, so they got more right than they got wrong. So that should be fairly obvious to you. Also, when you sort of look at these numbers, this number is greater than that number, this number is greater than that number, doesn't appear that there's much of an interaction. There could be, in the sense that maybe this is a smaller difference than this here, you know, one of those kinds of interactions like we'll talk about or have talked about. But that's what's going on with this particular study. So how do we set this up? So we're going to have some variables, right? So on the old test, you're going to have some hits, right? So let me bring up the data file so you can sort of see it. So the OT means the old expectancy test, and then I have an underscore here. The FA means it's a false alarm. The OT underscore hit means that it's a hit. So for this subject, you can see that these were the false alarms, these were the hits when they were told there are going to be more old items on the test. You have the same data for the NT test here as well, listed in the spreadsheet. And you can, in the data editor, of course, you can see we had 31 subjects here. All of their data is accounted for. We had an instructional issue, so that's why we started with 112. In our data set, we actually collected some data on some other people, but it wasn't working, so we had to change our procedures a little bit. So this is the actual data for the study itself. So now we want to create some syntax. So I've already created the syntax for you. A lot of the stuff, let me go over this. A lot of the stuff is going to be straightforward here. So what we have here, the cell info means, this will give us the means and standard deviations for each of those individual conditions. And then we'll get effect size and we'll get power out of the analysis as well. So here's our listing of our variables. And this is really important because you want to list them in a particular order. So what we're listing here is we're listing, if you notice, this is false alarms, this is false alarms, hits, and hits, right? And then you have NT test, OT test, NT test, OT test, right? So what's repeating more frequently in this list is test, and there's two levels. So NT, OT, NT, OT, right? That's what's repeating more frequently. So that's why we have this variable to the far right with two levels. The other variable also has two levels. So you're telling SPSS it's a 2 by 2, or you're going to have a total of 4 variables. It repeats less often. So if you notice, these two together are false alarms. These two together are hits. And so when you put it together like that, the item variable is going to capture the difference between hits and false alarms. The test variable is going to capture any difference between the OT test and the NT test overall. And of course, you're going to get an interaction. So if we run this, we'll look at the output. So we run it. So we're going to look at the output. So we're scrolling down. And so here are the means and standard deviations. That's what I put in the paint picture before. That's where I got this information from. You can see those are the values, and we have 31 subjects. That's all good. When you scroll down, the first thing you're going to see is the between subject effects. You want to ignore that. This is trend analysis. We're going to ignore that. First thing that comes up that we're going to pay attention to is item. So item, you can see here, is significant. So we want to look at significant of F. Remember, we're looking to see that it's less than 0.05. And the relevant information, degrees of freedom, so you have 30 degrees of freedom. There's your F value, and there's your P value. And let me shoot over to Word here so you can sort of see. Let me see if I can position them so you can see both of them at the same time, or we can maybe, yeah, that'll work. So what we're looking at here is a item main effect, right? And so we're going to have an F with 30 degrees of freedom, and the F value itself is 93.45, and the P value here is, it's not 0, right, but it's less than 0.1. So your your APA text would report it this way. Remember that we're going to have it Times New Roman, 12-point font, and you want this to be italicized, and you want the F and the P are italicized because they're statistics, right? So that's the first result taken from our output, and you would end up writing it up and using this piece of information in your writing. All right, so that's the item. So the test similarly also is significant. So that tells us there is a difference between the two tests. So here we're going to test, and what I'm going to do is just copy this, and we'll just edit. And so it also has 130, but the F is both very large F's, 103.34, oops, 34, and of course the p is less than 0.001. And you can look at the effect size here too. So it's 77, 70, almost 78% of the variance. Quite big effects that we got here. Ditto here, roughly 76% of the variance there. So big effects. And then if we look at the interaction is not significant, right? This is greater than 0.05, right? So our interaction, I'll just be complete here. So we'll do the item by test interaction. Let's see if, yep, still have it in memory there. So we have F130, and this is going to be equal to 2.04. And here you could write p greater than 0.05, or you could write what the p-value actually equals, in this case 163, right? And that would make its way into the text. So that's how you do it. That's how you organize. The key thing is understanding that this ordering of the variables is very important. You want to have SPSS analyze and group the variables appropriately. This is the way you want to do it. There's additional handouts in Canvas for you in the SPSS guide that sort of explains this thoroughly, but I hope you find this example helpful.